Hello, my name is Katia Chamat, and today I will be going over the hybrid clustering algorithm solution that I've created. So, starting off with our agenda, the first is background. I'm going to talk about how we got here, what is the issue, and next is going to be looking into our hierarchical tree clustering approach. And the second, the k-means clustering approach, and a live demo of the actual code, and then a little assessment of the results and discussion. So, some background, hybrid clustering algorithm is a method of combining two clustering algorithms and using them to work together to improve the quality of results. So in this demonstration, I'm using agglomerative hybrid clustering algorithm and k-means clustering. Some pitfalls of traditional clustering methods, which means you're only using one, is that it doesn't have great robustness, right? It has poor robustness due to improper selection of initial cluster centroids. And if we don't have proper selection of those initial points, then information can get wonky. So, hierarchical clustering data analysis analyzes the data by iteratively grouping two data objects with the highest similarity until forming a single group. So, some benefits of this clustering is that it can handle large data sets effectively and is easy to implement. Some disadvantages are that it's computationally expensive and it does not produce the same number of clusters for different data sets. So we are looking for that consistency. And like I said, it's going to compare those two data sets until only one is left. All right, so in our code, we're going to load that data using our first approach. Then we're going to normalize the data within it with the normalized function and z-score. Once we obtain that, we are going to find our three clusters and display them in a dendrogram. Okay, so the next thing that you're going to see is we're going to take those results and put them into our k-mean clustering method, and it's commonly used for partitioning and organizing data into clusters. So this is going to be that optimization that we were talking about. Now, k-means uses centroid-based clustering, and the centroid of the cluster is the mean of all points in that cluster. So we'll see that as we go through our code. Our benefits are going to be centroid-based clustering organizes data into non-hierarchical clusters, and they are efficient, but they are sensitive to initial conditions and outliers, which is why we're using hierarchical clustering as our kind of primer for our k-means clustering. And so here's our approach that we're going to see in the code. You're going to see a old and new class label that will be compared to each other. That's going to generate our centroid. And then after that, we're measuring the distances between those centroids. And that's our desired result is going to be a matrix of our distances, right? And that's going to indicate the three distances between the data object and the three clusters. All right, and in our final steps, as we're looking at those shortest distances in each row, we're going to find the minimum for each row. We're going to find the minimum value along the column of the matrix, and then the minimum function returns two variables, the first and the minimum value. The first is the minimum value, and the second is the rank index of that minimum value. And then we apply our V measure. So let's get into our live demo. Okay, here you are going to see my live code for our hybrid clustering algorithm. Going through our steps here, we're loading in our data set, right? Step 2 is going to normalize that z-score, and then we get into our stage 1. So I'm just going to go ahead and run this, and I put a few breakpoints so we can see what's happening. So here, as you can see, we've gone through these first 5 steps, and you can see those variables created off to the side with the figure and is going to create a dendrogram. Here we go. So here's our first um, information that is going to be put into our initial for our k-means. And the next breakpoint is going to be that loop that we create that runs 3 times. That's going to compute the centroid value of all of our clusters. So we'll let this run. And as you can see, now we are getting more variables, and it's going to continue through this for 3 iterations. All right, we're going to step. There we go. Okay. So you can see we've stepped through the loop once. Now we're on the 3rd iteration of it. We've gotten our 3 distances, and now we're going to take those distances and we're going to put them inside of a p distribution function and name them distances. Right? We're going to just keep running this all the way through. It takes that and it creates a comparison of the columns, or yes, the column class label, and uses the minimum distances of the rows and the second column. So we are using this output, and we're also comparing it to the ground truth label. So using vMeasure function, we're going to ensure optimal performance to compare the class label and the ground truth label. So with our 2 algorithms, it's going to give us these results that we can use to compare that will ultimately give us this final result. Okay, so that concludes my presentation. Since we have a little extra time, what I want to do is go into some of the variables. So I restarted the code and I brought us back to the first set of output after we get our dendrogram. And now we are about to start comparing our old class label. So we have about 1, 2, 3, 4, 5, 6. Yeah, we have about 6 variables here that we've created. And so as you see, this next step, I'm going to start comparing, and I'm going to get an old class label now, right? I'm going to step in again, and it's going to create some more variables. And you can see now that old class label is here, and we have our member index created, our member data that's created, which is our member index, and it's normalized, right? We're going to continue to step, and we're going to keep doing that for 3 iterations. And let's step out so it will just, okay. And so if you saw here, our member data, our member index, and the normalized data and old class label are being updated during each of those iterations. And to go inside of them, we would see these numbers changing, right? During each iteration, the index, this here tells us, okay, kind of see our indexes are being grouped together, right? You can look at our old class label and the species associated with that, Setosa. Okay. All right, so that concludes my presentation on hybrid clustering algorithm. Please let me know if you have any questions.